Okay, so guys, this is the case of 3D force member. I will state now the conditions so that this 3 force member could be in equilibrium. Basically, guys, we have two cases where the 3 force member could be in equilibrium. The first one is that all the forces should be concurrent in one point. So if I have this case, then I could have equilibrium because I also have other conditions like the sum of forces is equal to 0 in vector form. And the second case where I could have equilibrium if they are all parallel. So I have three forces that are parallel. So let's start by the first one, which states that the forces are concurrent, and prove why, guys, I should have some concurrent force. So guys, let's take this body and assume that I have 3 forces. So let's say this is F1, this is F2, and basically this is F3. Okay, so basically F3 should be downward so that I can have some equilibrium and sum of forces equal to 0. So guys, I know that each two lines that are not parallel are concurrent in a point. So let's take these two lines here. So F1 and F3 are concurrent on this point right here. And assume that this is point O. I know, of course, guys, that the first condition of equilibrium is that F1 plus F2 plus F3 is equal to 0 in vector form, or sum of Fx is equal to 0, sum of Fy is equal to 0. Now let's take the third equation, which is the sum of moments, and let's do it, guys, where? What do you think? Yes, at O. So let's do it at O. So if the sum of moments at O is equal to 0, this means what, guys? I know that F1 and F3 are passing by O, which means, guys, that MF1 and MF3 should be equal to 0 because they are basically passing through. So the only moment that I have in this body or in this moment equation is the moment of F2. So the moment of F2 is equal to 0 means what? This means, guys, that F2 should also be passing through O. Okay, so F2, guys, here, this is not correct, and F2 should pass by O, or I will never have an equilibrium. So this could be F2. Now, guys, you have to know that this is not the only condition. So this is a very necessary condition to have equilibrium. They should be concurrent or they should be parallel. We'll talk about this later. However, guys, this is not the only condition. I should also do sum of Fx and also do sum of Fy. So the first case that could have equilibrium in a 3 force member is that they have to be concurrent at one point. Now, what if they are all parallel? Guys, this is an example of 3 force members where 2 of them are parallel and 1 is not parallel, and I want to prove now that in order to have equilibrium, F3 should be parallel to F1 and F2, so that our case is the 3 force members, is a 3 force member having 3 parallel forces. In fact, guys, if any 2 of these forces are parallel, I should have that the third one is also parallel to them. And this is basically, guys, because in fact, if I want to apply the first case of 3 concurrent forces at one point, on this case right here, I will have a contradiction. In fact, let's say, guys, that F3 is not parallel to F1 and F2, which means, guys, that there is a point of intersection of F3 and F1, or between F3 and F2. And I know, guys, that from the previous case, if F3 and F1 are intersecting on one point, this means that F2 should be intersecting the same point. So F2 should be intersecting on the same point O, and this is impossible because F1 is parallel to F2. And from here, guys, since I have a contradiction to the given that states that F1 and F2 are parallel, this means that F3 could not be intersecting O, or could not, F3 and F1 could not be intersecting the same point. What does this mean? If F3 and F1 could not be intersecting the same point, this means, guys, that F3 should be parallel to F1, and this is what I mean by 3 parallel forces. So this should be F3. Okay, so you can apply this for F2. So if F3 is not parallel to F2, so guys, this is how to prove that they are parallel. First of all, I know from the given that F1 is parallel to F2. So this is my given. If my solution is contradiction to the given, then this means that my assumption is not correct. So I know that F1 is parallel to F2. What I want to do now is to assume that F3 is not parallel to F1 and F2. So if F3 is not parallel to F1 and F2, this means that F3 is intersecting F2 and it is intersecting F1. So if F3 is intersecting F2, this means, guys, that from the first case of 3 force members, F1 should also intersecting F3 and F2, and this is impossible because F1 is parallel to F2, which means that F3 could not be intersecting F2 or F1, and this means that F3 is parallel to F1 and F2. Okay, so guys, I'm saying here that in 3 force members, in order to have equilibrium, I should have these 2 necessary but not sufficient conditions. Okay, because I also have other conditions like the sum of forces equal to 0. Okay, so they are necessary but they are not sufficient. Okay, so the first case that they are the forces, basically the 3 forces, are concurrent at one point, of course. And the second case is that the 3 forces are parallel to the 3 forces are all parallel. Okay, so guys, as I said before, 2 and the 3 force members are very important later on because it will simplify and facilitate our problems. Now guys, I want to introduce 2 particular cases, and they are also important because I can ask you, what is the type of this member? Is it statically determinant or statically indeterminate? And you should know how. In fact, it is statically determinant if the number of unknowns is equal to the number of equations. So I know from 2D that the number of equations is equal to 3. This means that the number of unknowns should be equal to 3 in 2D. So if I take the first case here, I have a fixed support, and this means that I have 3 reactions: moment, vertical and horizontal reaction. This means, guys, that this beam here or this body is statically determinant. I can determine my unknowns. Now in this case here, guys, as you can see, I have a fixed support, so I have 3 reactions here. I have a roller, which means I have a reaction here, another reaction here. So how many unknowns do I have in this problem? 1, 2, 3, 4, 5, and I know that in 2D I only have 3 equations, which means I cannot find them, which means, guys, this beam or this body is statically indeterminate, or it is also called redundant constraints. So I have redundant constraints. So guys, here this beam is called statically indeterminate because I have more unknowns than the number of equations for equilibrium. So another case is called improper constraints. What does this mean? Improper constraints means that there is always instability. I could not have equilibrium. I cannot have stability. And this is, guys, occurs when all my reactive forces are concurrent at the point this body is improperly constrained. Like this case, guys. So I know, guys, from this case that this is what? This is basically a pen, so I have two reactions. And this is a roller, so I only have one reaction. So basically this is a statically determinate beam. However, it is not stable because, as you can see, guys, if I take the sum of moment around A, so let's take the sum of moment around A. There is no moment for this force, there is no moment for this force, there is no moment for this force. However, I have a moment for this P, and it is Py, because Px is also passing through A, it is Py times this distance. Py is not zero, the distance is not zero. So I have a moment, I'm saying that the moment of P is equal to zero. So as if I'm saying that 10 kilonewton meter is equal to zero, which is impossible. And this is the case of improper constraint. Now here I have a 3D case. I know I have not talked yet about the 3D case, but in this case, guys, I have three reactions at this point, three reactions at this point, and I can solve for six unknowns in 3D because I have 6 equations. And then, guys, I have a force P here that has a distance D from this axe AB. So, guys, if I take the sum of moments around this axe AB, okay, I can take the sum of moment around any point, around any axis. So I know, guys, that all my forces are passing through this axis. So I only have one force that is not passing through this axis, which is the force P. And I know that the moment of P is not zero. It is P times the distance to this axis, which means, guys, I'm saying that a number that is not equal to zero should be equal to zero to have a stability, which means, guys, this is impossible, and this will cause instability, and this is the case of improper constraint. So I will stop here, and the following video will be about the 3D case in this chapter. Thank you.